Good afternoon, everyone. Welcome to GeekyAnts. We call it Geek Base, and that's what we do. Like on an like short word, we research, we collaborate across great teams, and we end of the day build great products. I'm a host for today. My name is Adintam Ganguly. I'm an engineering manager over here at GeekyAnts. So before we dig dive into the hardcore meetup, I tried to present what all we do and what all we have achieved so far, right? So we arrange great conferences and we take part on those. So we have been in almost all the major conferences across the globe so far. We build great products, right? So native base and BlueStack are some of them, which we are immense proud about. So you have almost around 20K starts in GitHub on the native based official repository, and then we kind of started thinking of to build something similar for like all the frameworks. So that's when we started for BlueStack. So you can go ahead and subscribe to the newsletter, BlueStack newsletter, and then apart from that, we have been trusted by the industry leaders. We have been like certified partners with a lot of industry like champions. We have almost around 135,000 odd followers in our official LinkedIn channel. LinkedIn page. So that shows the appreciation also that we got, right? So we have done like endless open source contribution, be it React, React Native, Flutter, any. I mean, you pick up any open source framework, you will be finding our commits over there. And then like end of the day, the motto is to build some great products, and definitely we have a lot of fun each and every day. So we recently had a Premier League. So we called it Weekend Premier Leagues 1.2, and that was a super massive success. So that's how our day out life looks like. um, cool. So coming to this meetup, so it is like this is the first time also I think we are mentioning Next.js in a React meetup. So I'm excited to see you all over there, and it's good to see a lot of new faces in a Saturday afternoon. So thank you all for coming on a weekend to make this meetup happen. And we have some amazing speakers lined up. So we'll start with Pranab Pandey. So he's an engineering manager at GeekyAnts. So he'll be an in-house speaker. So he'll walk us through building and data intensive supply chain dashboards incrementally with the help of micro frontends. The next we have Shayan, who will be speaking about building production grade monorepos for React and React Native applications. The third speaker is Himanshu. He will be walking us through improving the performances with React.js. And the last again we have an in-house developer, Cyrus. He will be walking us through the changes of our next 13.4. Feel free to connect to this Wi-Fi at any point if you guys are facing any network issues. So this should be good enough. You can take a snapshot or a picture of the screen, and you can connect to it back later. A few code of conducts, please do not use any hate speech and any inappropriate comments. Keep it light enough. Be respectful to your fellow partners, and refrain from strong words. This is space for growth and learning, so please promote that, and get to know your fellow attendees and speakers. This is a place to build your network, which will eventually help you out at some later stage of your life. Cheers to that, and I hope to have a great meetup ahead. So let's get started. I'll hand it over to Saurav, our very own CTO. He'll be the keynote speaker for today. Saurav, over to you. Yes, Saurav.
Thank you, Arindam. Not a good thing to ask on a Saturday afternoon, but let me ask you, how is the Josh? Doesn't feel like. Come on, one more time. How is the Josh? That's like it. I am Saurabh, and I am delighted to welcome you all to the React and Next.js meetup of the evening. Before we begin, can I ask a question? How many of you are React developers over here? Almost all of you, as I expected it. And how many of you have used Next.js in your applications? Quite a few. So that's since we are having the Next.js meetup for the first time, I thought let's start with why not think about why do we need Next.js and why do React.js developers prefer Next.js as their go-to framework. That's me. I'm Saurabh, your keynote speaker of the day. So, for those who don't know, Next.js, it's a framework by Vercel. It's an open source framework to build high quality React.js web application, which gives a lot of structuring to your applications. Some of the key features I have jotted down that helps you develop good high performant apps is server side rendering, which is by default included in Next.js. What it does is your pages are rendered at the server side and the rendered page is sent to the client, where you don't need to worry a lot about SEO things. The search engines can crawl your pages, index it, so your ranking can go up. So it is by default included in Next.js. Then I really like about something in built in Next.js is static site generation, which is like your pages are generated at the build time and your pages can be served as a static files. You don't need to worry about like rendering lot of things going on. The use case of this can be something which is a blog app or something which where you are documentation of your applications, where you know that with each request there won't be lot of changes going on with your each request. So in those cases, static site generation can boost your performance hugely. Then Next.js also provides image, font, and script optimizations. For example, the if you use the Next.js image component, it does the lazy loading for you by default, and you don't have to worry about all those things. And if you are requesting from a smaller device, say mobile, then it auto resizes the images and gives you a better low size image, so that you don't have to worry about the performance. It is already optimized. It lazy loads for you. Same things it does for fonts, scripts. So a lot of such enhancements can help you boost your experiences. And if you are a TypeScript fan, then definitely Next.js supports all the out of box TypeScript support is already there. So moving on, I just wanted to update you guys what we have been up to at GeekyAnts, what we have been building with React and Next.js at GeekyAnts. So we have been working on a framework named GlueStack, which is a one-stop solution, full stack framework for building web, mobile, and backend. So like what Next.js had for React, like it included React and enhanced the web application. We have been using Next at our web application, Expo for mobile apps, and entire backend structure is there in GlueStack. Please check it out at gluestack.io. I'm not sure why this not taking this page. Is it changing? One second. I guess there is some layover of VPNs. But anyways, let's move on. We have also got some in-house React core contributors: Meenu, Viraj, Madhav, Ankit, Cyrus, Mayank. They have done a pull request on React and React Native, and their PR has been merged. They can proudly call them the core contributors of Expo and React Native. Big shout out goes to them. Moving on, if you want to be stay up to date with what types of talks, what types of podcasts, the meetups we are organizing, you can follow us on LinkedIn with the name of React Wizards, and on Twitter it is also React Wizard. Please follow us to stay up to date with these types of talk and things going around in the community. We have also partnered with Vercel. What does this partnership does is that we get a lot of advanced features, the demos of the beta things from the Vercel, and we have the live support from them. So this partnership is helping us, enhance our entire web app development experience. We have also partnered with Hasura, GitHub, uh, And yes, we are partnered with GitHub. Even after partnering with GitHub, we are not getting Copilot as a free thing. Anyways, let's move on. So that's all from my side. I would like to hand over to Arindam. Please enjoy the talks, communicate, and ask a lot of questions. Have a good day. Thank you.
Great talk, sort of. I think that was really insightful, for the people who are joining us for the first time. So that's what we do, right? So we always believe in community-driven learning. The reason behind it is learning something new is great, but then unless you sort of, redistribute that knowledge to the fellow communities, that the learning cycle doesn't get completed, right? So in GeekyAnts, we have been enforcing on community-driven learning from the day one, and then I think a lot of appreciations and leads that we get are from the communities itself. So that's what shows our love for communities. Cool. So I forgot to mention a couple of things right earlier. So the structure is going to, so we'll have like two speakers at the beginning. Then followed by that, we'll have a break of around 20 minutes. So you guys can go ahead and grab some drinks, have some refreshments, and then we'll come back with the two other speakers. At the end, we'll be ending the meetup or the session with a panel discussion sort of things. And at any time, like if you guys face any difficulties on accessing anything, you can reach out to me or Sana, right? So I'll be there for helping you guys. Cool. So I think that's enough. So let's start. The main agenda today. So I'll invite on stage Pranav Pandey, an in-house engineer who will be walking us through his data-intensive supply chain dashboard using micro frontends. Over to you, Pranav.
Three squares that we're seeing there. That's fine. Okay, hi. My name is Pranav. I work as an engineering manager right now at GeekyAnts. It's been almost 6 years with the organization right now. Started off as a developer and then, added responsibilities. And now I'm a engineering manager. So for the last 3 years, just to give an introduction, like what we've been working on is that I've been working on an application which is pretty big. It's a supply chain dashboard for an organization, and uh, we've run into a lot of issues, solved a lot of issues, found a lot of learnings through that process, a lot of things that we shouldn't have done, a lot of things that we should have done. So what I'll be doing today is that I'll be taking you through that journey basically. Um, let's start. Okay. The basics of a supply chain dashboard. So when I say supply chain dashboards, what do you guys think it is? Is it a simple dashboard? You have like 100 items displayed. You have your tables. You have your uh, you know you have some data visualization, and that's it. But when we talk about large scale supply chain applications, the way they work is that each page and each grid, and there is not one, there are like multiple grids, and each of them are going to hold records that will exceed 5,000 at any given point of time. And this application that you're building, you can start off in any manner. You can start with a CRA, you can start with a ejected app also, you can start with a next app or whatever you can choose. But the problem is that once you start with one code base and you start building this, then you run into issues not at that point but a year later, because that is when your team will decide to scale. That is when your team will decide to say, hey, I need more features, this doesn't look enough. The end users, the people who use your application, they now have requirements. They're like, hey, we like this, we like what you've built, but can we have this feature uh, along with this? Is that doable? And then at that point of time, your architecture, will it support it or not, becomes kind of a slippery slope, because you started out with one code base and now you don't know, if I change this, what's going to happen, how many components is this going to affect. So one of the basics is the size of the application. The second one would be user management. When I say user management, a supply chain dashboard typically does not have a lot of users as, say, a social media site, right? It will never have those kind of users. But what it does have is that each one of the users on a supply chain dashboard will have different roles. They are not all the same users. You play around with permissions a lot. So what you're doing is that each person who's logging in gets modular access to your application, and they can access parts of it. Only, for example, admins or super admins can access all of your application. But apart from them, it's very modular, and that proves to be a problem if you stop handling your permissions correctly in your one code base. But yeah, that's one of the problems that happens down the line. Effective data visualization, yes, again, when you are having the kind of records that I talked about, like which are in excess of 5,000, you can't just scroll through that. You need good visual representation so that whoever logs in, whoever looks at your dashboard knows that, hey, okay, this is what I'm looking at. 3,000 of these are done. These are pending. These are done from my side. This is pending on someone else. And they can get an idea of what the state of the application is. And that's very important on a supply chain dashboard. Order fulfillment and shipment tracking is basically, if there are like multiple entities that are logged into it, you need to make sure that if you have made an order, you need to track it, you need to see if it's done, if it's returned, if it's defected, and all of it needs to be tracked. Because when you're talking about supply chain dashboard, it's between, for example, a manufacturer and a supplier on the other side, right? And they're sending stuff, and there will be a lot of cases where you're not satisfied with it, or you're not satisfied with the pricing, or you're not satisfied with the material, and those things will play into it. So we need effective way to track them so that we can put them requests for changes and stuff like that. The next part is something in addition, but I feel it's something that's very important, which is a communication channel. So ideally, if, for example, you say there's a manufacturer and there's a supplier, right? Now, what happens is that if they don't have a communication channel, they will fall back to their usual communication channels, which is an email, or if an organization has Slack. But each supplier, for example, is a member of another organization, and to onboard them on something like Slack would be a bigger pain than using it actually. So they will fall back on using emails. But if you built an inbuilt communication channel into your dashboard serves as the one-stop solution for everything. They don't have to leave your application. So that's also an important thing that we can usually add it at the end. But yeah, if you can build it from the start, that's even better. So these are kind of things that we are looking at when you're building a supply chain dashboard. We started with building a supply chain dashboard, not knowing the scale of what we are building. Um, we started with a CRA app. Everybody here has done it, right? We started with the CRA app. We said, hey, what's the problem? We can go ahead and build it. There's no issue. We started building it. We built one table. It had around 2,000 records. We were fine. We dealt a bunch of issues with performance, but apart from that, we were good. Okay, then came another screen that had linked to 5 other screens. Now our code base started to get so heavy. Each deployment was taking 20 minutes to complete because the code base started getting so heavy that we just couldn't deal with it. Like if there's one change coming through, a change request, now we need to make sure that 50 components that use that small piece of code are not getting affected. So first of the things is you need like a huge test coverage. just to have it, and we didn't have that also at the start. So it was a very slippery slope, and we could see that this is not going to improve soon. So that's the complexities that we started facing with that application. So no separation of concerns. When I say no separation of concern, it means a, a component that I've built is not serving one purpose. It's serving a bunch of applications in different ways. And that's a problem. If it's a shared component, it makes sense. Yes, hey, this is a searchable drop down. Go ahead, every part of your application can go ahead and utilize it. That can be shared. But if it's specific for some function, then it should remain so. It should not be configured along with that with some additional props, and you're trying to configure it for another use case. So there's no separation of concern. Overwriting of existing changes. This was another big issue. I finish a ticket. I say, hey, okay, this task is done, done. 2 months later, some other developer onboards. He gets a task to change it. Both of them are using the same component. You make some changes. My code, which is in prod, which I did not touch, which did not have any changes, now suddenly breaks. Yeah, there's another inquiry. Why is this happening now? So that was one of the big problems, the practical problems that we faced. No independent deployments. Yes. So you are always dependent on the rest of the application. So if all of your code is, for example, on one branch, right? You're in QA, for example, and then you want to go to stage. Now you want to do a QA to stage, but you're not sure all of your code in QA is ready to go to stage and go to release, right? And then you get into problems because the whole deployment is controlled at a singular point, and now your whole application gets deployed whether you want it or not. Release plans, I don't want to talk about this. The problem with release plans was that exactly the thing that I talked about. QA to your higher branch, for example, stage, if you're going to, for each release, we started having 20 commits, right? We started having 50 commits. The team size was close to 35 developers. Each release started to have more than 200 commits, which had to be cherry picked. If there are conflicts, they need to be resolved. There's one person who's responsible for all of this, the DevOps guy. He's losing his head. There's no way he can do this without a lot of input from each developer. So each developer needs to come sit with him for 20 minutes and say, hey, no, pick this one. This is actually my code. I want this. And then we basically developed for 1 week and we released for the other week. There was a 2 week sprint, and we developed for one and we released for one, which was not something that we really wanted to. So how do we solve these problems? And mind you, we are in production right now. We have a lot of end users right now. So what do we do at this point? The solution was micro frontends. We explored a couple of options, but this was the most straightforward thing that we saw at that point of time. It made sense, especially because supply chain dashboards kind of serve the exact purpose for which micro frontends are ideally built for, because you have modular access, but you don't have a lot of connection between one part and another. So for example, if your supplier logs in and they try to access their admin screens where they update their address, hey, this is my address. If you want to pick stuff up from this supplier, you go to this address, right? They have their admin portal. That admin portal is not at all related to if an admin or a guy who is associated with purchasing logs in and sees the list of orders. He cannot change those values because it's a supplier address. He doesn't need to view those. He can view those, but he'll view those when he actually orders some parts, right? There's no reason for him to view those. So it gives a very, it's an exact use case for us. So yeah, what it does basically, a small introduction about micro frontends. It decomposes a monolithic front-end app into smaller units. So when I say monolith, it means, for example, you have your CRA app, or you can have a Next app for that matter, or you can have an ejected app, which you've already ejected. But the whole point is the code base is singular. There's a single entry point, and all of your modules are hosted inside of the same space, right? So what do micro frontends do is we take out modules. Each module that's not going to interact a lot, and that's a decision that you will have to make. Like where you draw the line on how much it interacts with with the existing part of your dashboard, and how much can be separated out. So that's a thin line, but you have to draw it once as a developer. You decide that, hey, I want to go ahead and delete this into like 5 parts. So you decide what functionality goes into which which of your modules. So it enables engineering teams to control their own deployments. Sure. So if I want to deploy, I'm not waiting on the other team. You can go ahead, deploy at your pace. If I'm done quickly, I want to do 1 week sprints and I want to have a release after each sprint. I can do it. I don't need to care about your code, or if it's moving fine or not. Maybe they have some blockers. Maybe those are genuine. Like, you don't really need to care about what the other team is doing. Avoids technology lock-ins. This is another thing. So I want to use Material UI. The other team wants to use Vanilla Extract. Now we are kind of stuck. We're having to and fro that, hey, this is the benefit of using an inbuilt library. They're like, I can build it myself. And then they want to use Vanilla Extract. So you don't really, there's no lock-in. You can go ahead, you can use your own state management. You want to still use Redux, go ahead. You want to use context, go ahead. Whatever you want. uh, which is a great thing to have, especially once the team gets bigger. Client side composition. So the way we built micro frontends was client side composition. So everything was happening in the browser. All our main shell app and the micro frontends that we've built, all of it survives together in the browser. That's where it's compiled. Enhances scalability. Yeah, so this is again goes back to the first point, which is like multiple engineering teams controlling their own deployments. So you can scale, you can say, hey, I want to just expand on this feature without affecting anything else, and you can pretty easily do that. So there are a lot of benefits, but yeah, so how do you actually implement this though? Okay, so this here is an example of a supply chain dashboard, for example, right? So you can see the nav bar. It's a pretty overcrowded nav bar. Um, there are a bunch of drop downs that you see, each of them pertaining to a specific use case and to a set of approximately 50 screens, each of them. And all of this, when we started off, was surviving in like one application for us. So our task became basically to divide this dashboard into a lot of smaller chunks, and each of and assign which team will work on that part of it. So each of these drop downs, we broke it down into an individual micro front end, and you could not even stop at that. For example, if you look at there's a column that says RFQ summary, there's a column that says new part releases, right? New part releases is a graph display. RFQ summary is a metrics display that we are seeing. You can go ahead and host both of them in separate micro frontends, or the dashboard that you see below in the loading state. You can go ahead and put that into a separate micro frontend, and all of your three big contents that you see on this page can survive on their own. They have no dependency. You can use your own styling if your dashboard needs some external libraries, right? Which the other libraries don't really want to. You can go ahead and use it. Um, but it's your call. Like, at what point, as I mentioned, do you want to break all of this? We didn't, because the APIs, everything was similar, and these actions were not taking a lot of time. There was no point in breaking this down because there was not a lot of visual dependency or a lot of graphs there that were taking time to render. So we decided to break this down, each of these drop downs, into separate micro frontends. I'll give an example now. So, for example, if you have your application, right, it's hosted, you have a URL, that's the URL that you access. How do you break it down into a micro frontend? First thing, you create a shell app. So, first things first, don't create a CRA app when you start to do this. You can, there's not to say that you can't, you can for sure, but you will need your Webpack config file. So eventually you will have to export it out, right? So you have to eject your app basically. So try to start with a plain npm init your JavaScript application, add a Webpack config, add a package.json, and just get at it. So what you do with your shell app is that it consumes all your micro frontends. So the task of the shell app right now is just to take in all the micro frontends and display them wherever they are supposed to be displayed. So for example, in the previous, yeah, in this view, you can see the navbar, right? The navbar can ideally survive in a shot dependent on each of the micro frontends. But as soon as you click on that drop down, as soon as you link that route, right, but the component that you return can be a micro frontend, whether you want to return your dashboard or your metrics, right? So these are, for example, each MFE that you have, metrics and dashboard. Each MFE has its own backend environment. You can host it separately, and all it's doing is serving your front end, and it's not dealing with anything else. If there are like common functions, you can export them. If you're, for example, using an AWS environment, right, you can export them into a Lambda or somewhere. But the backend itself, the schema of it, it's hosted separately, no connection to the other MFE. Along with this, you can also use your shared component libraries on the side, or you can use some grid libraries that you want, for example, AG Grid, or you can have some other shared libraries as well. So your shared component library is like, which follows your basically your organization's design system and builds components up, right? That can be a common library that all of your applications use, your shell app, your dashboard FE, and your metrics FE. And it just has to be installed in each of them, directly use it, no changes. Okay, let's get into a bit of code now. I've just taken out parts of it, not the whole code base. So I'm just going to show you the Webpack config. So this is my shell app, which is the parent app, which combines all the individual applications, right? So what I'm doing here is that I'm adding a new module federation plugin. So I'm using Webpack with module federation. Webpack 5 has some great improvements to use module federation. So for example, I've named this as my shell, and I've added a remote to it. What's my remote? It's running on my localhost 4000 at moduleentry.js. So it's a simple app, like when you run a normal app on when you do a yarn start, right? For a CRA, or if you're doing a yarn start for a Webpack ejected build. Either way, this is where my app is running. So this is completely runtime though. So what's happening here is that this shell app is running on 3000, but the 4000 is for my micro front end. I'll come back to the line at the bottom, but yeah. So this here is my MFE. This is my individual micro front end, like dashboards FE or my metrics FE. What it does is it exposes what's the entry name of the file and what's the name of my mod plugin, basically the one that I'm adding, and what does this module actually expose. So I've currently exposed the app, which is src/app, and along with it I created a button. So it's a small button component, and I'm trying to export that also from the same micro frontend. I could go ahead and host this button in another micro frontend, and all I'll need to do is just change the access, the remote access of this application. So this one currently exposes app and button. How would you go ahead and use this? So run this application on 4000. Go ahead, and your shell is running at 3000. Now, how do you use it is a lazy import on your remote. So we defined that as remote, where our individual MFEs was hosted. And what we're doing is we are just importing what we exposed. We exposed app, we exposed button. We're importing both of those. We go ahead and render them here. So I'm in the host, which means I'm in the shell. I've just rendered an application. The remote app key that I'm seeing here is not a part of this application, nor is the remote button. Both of these are coming from their individual micro frontends, but I can easily render them here. Show up this, pardon my CSS, but yeah, this is how it shows up. The button that you see and the hello from the other side is basically coming from another application. You can run all of this together in your shell. This is a very basic example of how you run these micro frontends. It's not very difficult. It's just Webpack config. Don't ever fear Webpack config. It's new sometimes to us, but it's pretty straightforward. Okay. Nice. So one of the main things that we found after we did this was that our application became like a rainbow. We could not identify which element was where. Instead of the dashboard, it was covered with a red background. Instead of my metrics, I am seeing the component elongated even bigger than my whole screen. So it was all a mess. You could not see anything on the whole application. And this is a prod app that we're talking about, right? What was actually happening was that each MFE was using Material UI. And Material UI is great and it works very fine. In development, it does not care. So in development, what's going to happen is you assign a class name, right? You assign a class name to your div. You say it's hero content, and you make a bunch of changes to it. You say, I want to give it a padding and this. So what it's going to do in your dev environment is that it's going to append it with your make styles, which Material UI exposes. And then it's going to assign whatever padding was there, and this is fine. We have no issues with it. But in production build, what happens is that it tries to save a lot of space. When it wants to save space, this long name dot make styles hyphen hero content hyphen 2 is too long for it. So what it does, it randomly generates strings which it assigns to those specific styles that you've defined there. Like for example, whatever your padding is. So for example, it defines JSS1 as, and it defines your padding as 8. Now the problem is multiple MFEs are using the same library, and in the production build, all of them are creating multiple .jss1. One of them has a padding, one of them has a border, other has a specific height. And this problem is arising now because these micro frontends don't really talk to each other. This will never happen on a monolith architecture, right? Because they know that, hey, this is not unique, this is already created. So if in one micro frontend, these .jss1 will always be unique. It will be .jss1, .jss2, and so on. But multiple micro frontends, they don't know about this. So we didn't prepare for this, but this happened. So we started looking into it. Material UI, on its behalf, it knew about this. It basically provides us with a create generate class name, which provides you an access to basically enhance it and make your own class names. You add a prefix to it, and each prefix is for a specific micro frontend, which is a unique name. Go ahead and add that prefix to your generated class name, which is like JSS1, JSS2, and then this becomes unique, and you never run into any issues with your styles basically. You pass this to the styles provider, which is again exported from the Material UI core. This was one of the big problems that we had, but yeah, it's solved pretty quickly. But yeah, we didn't account for this. Um, Fine. Some considerations before you jump to make application into a micro frontend. Migration from an existing architecture is a big task. You need to make sure all of your team is on board with this before you start doing this. The application that I worked on, I had to take out a lot, approximately 120 screens, and from an existing production application into a separate MFE. And I expected it to work as it is seamlessly, which is not going to happen. It took me 3 months to do it, which is a big task. But we did it after 2 years of development. So 2 years, 15 developers working on our app. So you can see the size of that application was. So it is going to be a big task. Make sure everybody's on board with it. Complexities in maintaining state and sharing information. So with MFEs, it's fine. You can use Redux. If you want to use context, go ahead. Use Mobex for that matter. It doesn't matter. But the problem is you have to pass down state from your shell. Now your shell has some kind of state, not a lot, but like for example, your global feature flags if you have, um, or your user objects, right? Those things you need to share to your MFEs to say, hey, this user is logged in, or if another user is logged out of it. So those things you have to pass down, but then you have to pass it as a variable because you're not using a state management library on shell per se, and each MFE does not really control it. So when you pass your data from your shell, you need to make sure that if you want to tweak it, then how can you do it? You need to pass a callback to do that, and yeah, a bunch of things. Which follows into challenges in auth sharing, which is exactly the same. Authorizing if the user is logged in, log out, how to inform the MFE that, hey, this user logged out from the shell, because the logout feature is not per se on the MFE, right? The MFE doesn't care about if the user is logged in or not. It does care, but it does not control it, is the problem. So that's another issue. Increased testing coverage. So now the problem is that end-to-end tests become difficult because each micro frontend is hosted in its own entity. And now end-to-end test cases, which run from, hey, the user is logging in and then he's interacting with like 5 different modules and logging out. The whole task becomes an issue because you have to go into each micro frontend. You have to take care of what they are trying to do in that micro frontend. Maybe the setup is completely different, then your test cases need to again tweak to that. So the best way is to have like a very good amount of coverage on each micro frontend, which helps you down the line. Like if that is good, then even if your end-to-end coverage is not possible in completion, you'd still be good. So that's something you need to do. So make sure you allocate time for that. That's one of the basic things. So these were kind of the learnings that we had from our movement. And yeah, now currently there are 8 micro frontends. Each micro frontend now deploys on its own pace. We don't need to wait for anyone. Like I just see 2 years ago the problems that we are in, and now we have completely resolved it. All the issues are only that, hey, plan our sprint, release our product. That's it. We don't care about anything, which is a great help. So yeah, these are kind of the main things. If you want to have a detailed look at, for example, I shared a couple of configs. If you want to have a detailed look, go to my GitHub. It's Pranav-Pandey. You can find a small repo there, clone it, fork it, tweak it. For example, if I'm running my local host on 4000, you can go ahead and run, for example, your builds, right? You can go ahead and run that, whatever changes you want to do, go ahead. I'm on Twitter at PranavPX. I wouldn't suggest you all to give me a follow, but yeah, I post a lot of football content more than tech, so that's there. Yeah, that's about it. Thank you for being a good audience. Thank you for listening. It's becoming a bit drab, is it? Everybody's kind of sleeping through this, but yeah, that's about it. Any questions? Go ahead, fire them. Yeah, go ahead.
Does the setup work with SSR?
Yeah.
Does this setup work seamlessly with SSR?
So this was a complete React application. We didn't really explore SSR, but I don't think there's any reason why it can't. Not this setup exactly, because this we are actually running our local host, right? So this is a very simplified version of this. But if you want, you can, because what is going to happen is that when you use SSR, your app build, all you need to do is serve it as soon as the shell app requests it, right? So as long as it's built and it's ready and you have the process to serve it, which you can do through Webpack, which is never an issue. So it is possible, but yeah, not exactly in this manner that I showed. Shouldn't be a problem. Yeah.
Can you shed some light on the maintenance and the cost, which obviously could be increased cost, right? When you,
Yes, yeah, for sure. So we, okay, I missed this thing. So I wanted to, yeah, this line that you see at the bottom, right? So we hosted all of our applications on Amplify. Um, as you know, AWS is pretty expensive. So you will incur that cost. I'm not going to say you will not. You will incur that cost. The point is, are the trade-offs good enough? Because when you have a development team the size of, like, 20, 30 developers, 15 QAs, this is a huge team. So are you willing to live with what you're doing, which is cherry picking for your releases, or are you living to, are you good with additional costs? Um, what happened was, in our team, the backend developers tried to resolve this by trying to cut costs when they used OpenSearch and a bunch of other backend lambdas, and they tried to configure it so that it uses very less resources. But yeah, we still got additional hike in our monthly expenditure on AWS for sure.
because I have this question because I read some article related Amazon said that they are microservices and because
Amazon Prime Video, yeah. I think Prime Video was it, yeah. So Prime Video moved to a monolithic architecture from React frontend. So this, which is, we are talking about the completely opposite thing, right? But if you deep dive into it, they still have 90% of their code hosted as micro frontends. What they did was their live streaming part, I think, was the one that they only pulled back into a monolith. So their code still is in micro frontends, but what they pulled back was only on their live streaming. So they served it from a singular point of view, which probably has its own benefits for them. But yeah,
that gives very mixed reaction about microservices.
correct. Yeah, there's another. Yeah, that discussion is also now going on. That, hey, why don't we go back to monoliths? What's the big deal about micro frontends? So it's, at the end of the day, it's about like what runs for you, basically. Go ahead. Yeah.
To reduce costs, I mean, we can, is it okay to have one server which will host all your microcontrollers on different ports? Like, cost can be, there will be still point of failure, but you will
Yeah.
get that trade-off.
Yeah, but then, yeah, you can do that. But see, the problem again would be that if it again goes back to a single point of failure, right? So that is one of the great benefits that you get out of this architecture. So you are losing out on that if you try to cut down on costs. Again, cost is very subjective, right? Like, for which organization can spend how much, it's dependent on them. But yeah, the one of the basic things is that I can deploy my module, and if somebody left a colon in their build, or did something stupid, and now my whole app is not down, and that's one of the great benefits that we do get with this.
So the way it works is there will be one server, and each of your repo will basically deploy to a particular port on the same machine, just the same process.
Okay.
So it's not affecting this, it's still mine.
Okay.
It's
Now
just
that's
hosted in a
interesting.
single
Yeah.
machine.
Okay. So the only case is if your server
Yeah,
as a whole
if your,
goes down.
if your shell app goes down, or if your container is killed
Hmm.
due to any
Yeah,
anything.
that's yeah. Yeah. No, that's a good option, I think. Yeah. For normal use cases, that's pretty good. Unless and until you have like a very vast thing that you're running and you need to make sure that each of these modules you can't go down, otherwise I'm losing a hell lot of money or something. But yeah, that's a good option. Anything else?
Have you also considered, versioning your releases in microcontent? So, for example, if there is a button
Hmm.
slash v1 will serve a button slash v2 will serve your new deployment, and you can revert to v1, v2.
So when we try to deploy this, what we're using is like local feature flags into our application. So we are kind of controlling it through that. For versioning, our SCL, our shared component library that we have, that has versioning. We're using semantic release, the package releases, and for communication channel that we are actually currently building right now, that also is a separate package on its own, which also uses semantic release with AWS code artifact. So that is also contained, like we are on 1.1.7, and I'll just go on there, and that is controlled because that's something external that you're using. But then there's also a separate team that kind of manages those. So there's no concept of that we run into breaking changes, right? Because once an update happens on that package, a whole end-to-end test case starts to run in our environment wherever it's updated. So we try to make sure that there's no breaking changes. But yeah, so only on our shared component libraries and packages we do have version control, not on the MFEs per se, but we can. That's not a problem. Yeah.
I mean, if a particular component is like shared in different streams and you want to roll out one by one, then that might be the use case. But that can be controlled by features like that.
Yeah. So if your module is small enough, you will be comfortable controlling it with a small local feature flag that you build into your .env file, for example, right? And you just control it right there. But depends on the scale, right? So if it's very bigger, if it's much bigger than that, then yeah, I wouldn't also move with feature flag. That's true. Yeah.
Do you think clubbing of more than one framework within this architecture, you tried something like that? Say you use both React Vue and
We didn't try it with this specific architecture in our product, but it's entirely possible. It shouldn't be. I think the only problem might be across your peer dependencies. So, for example, we do share the React version. Like all of our micro frontends do share the main React version with the shell app also, right? Um,
how the communication or is it okay for
So that's on the Webpack config. So if you see this screen right now, right, you can see the shared dependencies that I've mentioned. So it makes sure that the React and the React DOM are going to be installed once, and these are not going to be repeated across individual micro frontend on our main application. When we run the shell, when we run myhugeapp.com or whatever, right? At that point, these are the shared libraries. So we haven't tried it, but as long as your build is served, right, at the end of the day, we really don't, the application doesn't care. As long as something is served from the endpoint that you mentioned to it, it can use Vue for if you want, it can use anything that you want, like it can use solid.js or whatever. But
the combination versus what you
yeah, it will work, it will
say?
work.
Why? Because you have to be like when you're mentioning the metric dashboard and the other dashboard.
Right.
Say if you want to design something now, maybe you want to update the metric dashboard in future and then different flavor.
Right.
Alignment.
Yes, that's entirely possible. Like yeah, if you find a better implementation of a charts, right? If some framework gives you a lot of flexibility, a lot of improvement on your time it takes to render those, so you can go ahead and use that. And this is the freedom that you have. Like you can take a month or 2 months out, and you can say, I'm going to redo that whole component, and your application really would not be affected. Uh, okay. Anything else?
So actually, I had two questions, but one was already asked. That was cost factor. The second question is, we can do this with parcel or wait, right? It's not a web pack.
Yeah.
So
You
we
can.
always
We
know that.
we use Webpack 5 with module federation, but yes, if you want to use another bundler, that's completely fine. Shouldn't be a problem. You can use Parcel, but I'm not sure how Parcel is supports module federation or not. Then yeah, those are the questions that you need to explore. But yeah. Okay, that's it. Between, are you talking about between MFEs or are you talking about? So between MFEs, there's very minimal. If you want to do that communication, you'll have to do it through callbacks and functions, right? And that kind of dirties your shell basically. So we don't want to get into that. So ideally, the design should, everybody needs to be on board here. Like the design needs to make sure that you're not triggering your MFE from deep inside another module. You try not to do that. You try not to share a lot of information.
Can they have local statements? Like, if something happened in this, something in future,
Yes.
so that should be updated in some other.
It can happen, but you'll have to manually handle it with callback. So you have to pass your, hey, I'm selecting these two parts in this micro frontend, right? You need to pass a function that selects those two micro frontends, pass that callback into the MFE, pass it down to the exact route where that's happening, then trigger that callback from there, and then it flows all the way back. So it dirties your whole system, but yeah, it's possible. It's not that it's not possible. We've done it for a couple of use cases. That's also another option. If you want continuous subscription, then yeah. Okay, that's it. Thank you.
Okay, so great talk by Pranav. Looks like microfrontend has created a lot of buzz, right? And I know like you must have some other questions as well. So just a little change, like just to save time, we'll take all the questions in the panel discussions. As I told earlier, right? So you have discussion lined up after all the speakers are done. So we'll take all the questions after the panel discussion. You guys can write down your questions and save it for that time. Cool. So moving on to micro frontends, like where it emphasizes you to like work on distributed teams, so that your team also does not need the learning paths, right? So we have another. I mean, the next topic is monorepos. Like so, tech is interesting, isn't it? So let's try to dig dive more into it. So I'll welcome on stage Sayan. Sayan, you can take the stage and walk us through monorepos. I hope the buzz, like remains constant, so that we have more topics to discuss on the panel discussion.
Yep. Hi, I'm Himanshu. I'm part of the engineering team at ZenDuty, which is an end-to-end incident management platform. So we basically help companies minimize their downtime and meet their SLAs. If that went over your head, just know that when your favorite website goes down, send them to us. They won't go down as much. All right. And I'm going to be talking about building production-grade monorepos for React and React Native. So it's become obvious that JS has evolved far beyond just web apps that it was originally intended for, and is now building native mobile apps and desktop apps. These are great platforms to build for, and it is um, incredible that we can do this through a single JS code base. So, how many of you have built React Native apps? Yeah, it's a good number. It's a good number. And how many of you have tried building the same project in both React and React Native, or at least similar projects? Right? Maybe you start off. Yeah. That's a lot. So you start off as maybe a React app, and you decide, okay, this would be much better if we have a mobile app as well, right, or a native desktop app. So it's companies want to do this, devs want to do this, right? It is in the best interest of everyone to actually build for multiple platforms in a single code base, the code base, if you will. Okay. Um, More often than not, when you actually get into this, most people use a single code base for all of their applications. If as long as it is a single product, a single code base builds on all of your platforms, be it React, be it React Native, be it for mobile, be it for desktop, right? When you do implement an architecture such as this, you will eventually run into problems of how do you structure this? What should the structure look like? So you will not come into such a problem initially when you're setting it up, right? Initially, it's just create React app, create React Native app, and like you're good to go. But like Pranav said before me, the real challenges only come up a year later when you actually scale, or maybe 3 years later when you scale exponentially, right? That is when you actually start to think about problems like these. What should be the right architecture that we use? How do we make the dev experience as simple as possible? How do you make code changes as quick as possible so that you can make releases as fast as possible? How do you manage scalability, the current scale and the upcoming scale? These things like these actually end up boosting your productivity. All right. So we were plagued with this question as well at Zen Duty, and we considered a lot of approaches. Let me discuss some of the traditional approaches that you'll find online and approaches that we actually considered, right? So, one approach that people use to have React and React Native projects in the same code base is the same folder, but you'll probably have different suffixes. So, as you can see, a very difficult task is centering divs, as many people agree. Alright, it is a running meme, but ideally make a component for it. Don't, that's a joke. But most people will, let's say, have a .web and a .native or a .android and things like that. So you would have a single folder, and you would just have different suffixes, and you would pick up the respective files, right? This would leave your code base largely unnecessarily interweaved. Right? It's not scalable for large projects. Or maybe entirely different folder structures. Your mobile app is in a completely different folder, your web app is in a completely different folder. There is strong separation there, but how would you share code? Right? Let's say you've got a massive API layer that is common code with both web and native. How would you share this? You would have to have redundancy. The same file would be in multiple places. Now imagine someone made a very big change to that file, right? In only one of the places. Now what do? You're responsible for carrying over this massive change onto the other file. That it's just not scalable, right? Um, Another option that we have seen people use is conditional imports. So for React, you would just import the React component, and for native, you will import the native component manually. Every single file would have lines of just conditional operators. This creates clutter. You have Git submodules. So Git submodules can work in some cases, but they need to be implemented perfectly. Because how many of you have heard of Git submodules to begin with? Yeah, few people have heard of them. So what Git submodules do is basically they give you sub repos within repos. All right. So your native would be a separate sub module within your Git, and your web would be a separate sub module. They would each have their own version control. You would each be doing their commits separately. These commits would be separate, and the entire root workspace would also have its own repo, which is committed separately. So, listening to that itself sounds very tedious, right? And when you're working with large teams in parallel and working with a lot of branches in parallel, this can be very confusing. So, what is a good alternative to this? What is an alternative that worked very well for us? Introducing Yarn workspaces. Why is this so good? Yarn workspaces allow you to use a single Git repo to manage all of the projects that you have, the shared projects within the same workspace. You have multiple projects within the same repo, and you can define them as your own separate custom packages. Just look at how I've used Zen/API here. I've defined my own API layer, and I'm sharing it across all of my apps. You can share code without duplicates. If there's some code that you would like to use in multiple projects, just define it as a separate package. And you can easily import them in all of the apps that you use. Yarn workspaces have native support for dependency deduplication. Let's say you're using package one in both of your apps, and you have multiple load modules folders, right? So Yarn will automatically figure that out and not install package one multiple times. Right? It deduplicates that and installs it only in the root workspace. Yarn workspaces come with ton of additional benefits, which is why it has worked really well for us. So now the question is how? How do you move an existing large scale project to a monorepo? It's quite simple actually. You just get started with Yarn and you initialize your workspace. It's as simple as just defining your packages. All of the common code goes into something called a package, its own package per se, and you would just define it such as this. And after that, you can just import it in your applications. So let's say your web app is using your API, you just mark it there as a dependency, and you're good to go. That's all it is. Well, along with the fact that you will need to be doing some moving around, and how much moving around you will need to do entirely depends on how big your code base is, right? But that's the gist of it. Now, it's not all roses, right? What are some production grade challenges that we faced while moving a large code base to a Yarn monorepo? So, one challenge that we faced is ensuring shared code compatibility, right? So, when devs come in and decide to make drastic changes to the structure or the architecture, most of them tend to forget that a lot of this code was written 4 or 5 years ago, maybe decades ago. This is all legacy code that is still in production but is running very well, so nobody touches it. Okay, so there's probably even a comment there that says legacy code do not touch. Okay, but legacy code and a lot of intertwined code, all right? So let's say look at this hook, for example. So does anyone see the problem as to why this would not work in React Native? Right, you're referencing window.location, and that simply does not work on React Native. And things like this, you'll find a lot of tiny problems here and there that are make it incompatible. If these problems are few and far between, your easiest and quickest approach to get to production is just have simple checks here and there. Right? Simple checks can easily avoid it, and you could have your native specific code over there. Just get them out of the way with some conditional logic. Another challenge that we face is handling deeply entangled code. Let's say this, for example, this is an actual scenario that we faced. So you have, let's say you're trying to display a toast message, right? This particular file has code of React and React Native. They're both being imported in a single file, and there's no conditional logic in between. It's just the export that's changing, right? This is one example of deeply entangled code where it's incompatible. Let me tell you, does it, so to look at this, what to look, understand why this is a problem, you first need to understand why is this incompatible, right? How many of you think that this would work perfectly fine in both React and React Native without throwing any errors here and there? Because you see, is native, return that toast, and is it's not native, return the other toast, right? Seems like magic. No, because this is when you need to look into how bundlers work. So you see that React Native toast import over there, right? Your bundler looks at that, it's going to try to find out its dependencies. And React Native toast is most likely using React Native, right, for UI and things like that. But the question is, what is React Native using? How many imports does React Native do? Because your bundler is also going to crawl the imports that React Native is making, and it is a lot that is incompatible with React. Your bundler will try to crawl all of these and build a map out of this, which will simply fail on web. So what do you do when code is so deeply entangled and you cannot actually make changes in the file itself? Just exclude what does not work, right? So let's say you cannot make any change to the toast file. You simply have to just exclude React Native from your webpack. So it will just, what it will do is, while building its map, it will just go over there and it will just stop building the map at the excluded dependency. Simple. So as long as you don't reference that component anywhere in your web app, you will have no compilation issues. Another issue that we faced was sharing linter and formatter configs, right? It is a DevX dream to have a standard linter and formatter config across all of your projects, across all of your apps, all of your components, everything. A single editor config, a single formatter config, right? But how do you do this in monorepos? How do you do this without writing the same ESLint config over and over again? Yeah. So a simple approach to this is just extending. Through monorepos, it is easier than ever to just extend the one config that you have. You just define it as a package, and you can just extend your proprietary ESLint config, right? So it's quite simple, very clean approach. Now, another problem that we faced was having TypeScript and JavaScript projects in the same repo. How many of you have worked with TypeScript? Yeah, a lot, right? So when you have large code bases, right, with multiple projects, you can't be sure that all of them will be written in TypeScript as much as we would like it. Some projects are just too tedious to move to TypeScript. So we end up having some projects in TypeScript and some projects in JS, right? So when you have this in a monorepo, how do you deal with it, right? How do you deal with shared dependencies and packages and all that? Before we address that, let's get the parsers and linters and formatter configs out of the way. Let's say you want to use the same ESLint config and prettier config and all of that in your ESLint JS project and your TypeScript project. How do you do that? It would be nice. It's a great nice to have for the dev experience. Well, it is as simple as inheriting it there itself. You can inherit your ESLint config in your TS config. You just import it, you just require it there, and you can spread it and build upon that. You can add additional TypeScript specific config right there, and you're good to go. You now have the same ESLint config, prettier config, type config. It's all the same everywhere across all your projects. Zen. That is DevX Zen right there. Um, Now to address the elephant in the room, one of your project is in JS, one of your project is in TypeScript. What do you do to shared packages? Obviously, you cannot write them in TypeScript, right? Your compiler will just fail at that step. So they will have to be written in JS. But having your shared packages in JS and your React Native app in TypeScript it sort of reduces the efficacy of TypeScript, right? You would ideally want to have as much types as possible. Once you get into TypeScript, you just cannot stop having types. So, what do you do there? A simple answer to this is JS docs. How many of you have heard of JS docs? Not many? Interesting. But all of you have heard of TypeScript, right? Yeah. So JS docs allow you to get types into your code without actually adding your TypeScript compiler and additional overheads that come with TypeScript. But at ZenDuty, we took it even further. So instead of just having regular JS docs, we are actually importing types, d.ts files in JS docs. A lot of people do not know that this is possible. You can define your own d.ts files that are shared across your TS projects, and you can just import them in JS. You essentially have all of the IDE features of TypeScript, but without actually adding the TypeScript overhead to your compiler. Upon this, you can just add a TS check to your JS files, and you're golden in terms of IDE type checking without actually having TypeScript overheads. But again, in the world of monorepos, it's not all roses, right? There are some cases where you may not want to use a monorepo. What are these cases? Complex ownership structures. So I've been talking about having common packages that are shared here and there, right? But what if one of your packages were open source? Only your component library is open source, but your actual product is not open source, right? And they're in the same. What if they were in the same repo? That becomes very difficult to actually manage ownership, right? You cannot only expose a certain part. So complex ownership structures, partly open source code, things like these, monorepos may not be the right approach. Minimal overlap, where most of your code is just not shared, right? Where one project and the other project are just too vastly different from each other. Cases where it's easier to move to React Native Web. So if you are using React Native Web, you will not have to use React directly, right? Because your single React Native project can actually export for web, mobile, desktop, native, all of that stuff using the same code itself. You don't even have to deal with React directly. So if your code base is still in its infancy and you have not yet built upon it too much, consider whether React Native Web is feasible for you, because that makes things a lot easier. Volatile unrestricted merge policies. So let's say your code is really volatile, or let's say you have a lot of people pushing untested code where master can very easily break, right? You would not want volatile code in a monorepo. So the final verdict as to whether or not monorepos are right for you and your project entirely depend on a case-to-case basis. But if your use case matches anything that I've described here, or if the challenges that I mentioned seem interesting to you, you should definitely consider it. Thank you.
Thanks, Shan. Cool. So we'll take the debate again. Left behind for the panel discussion. So it's a time for break. So I'll give you guys a 10 minutes of break. So feel free to go and grab some drinks and snacks, and we'll meet at 4. I think 5:50, 4:40, 4:40. Okay. Welcome back, guys. Welcome back. I hope you made some really cool network and get presence fresh enough to start new again. Cool. So the next speaker we have is Himanshu. He will be his talk will be on improving performance with React.js. So Himanshu, over to you.
Hello everyone. Mic is working, right? So my name is Himanshu. I am with G from past couple of years, and in my experience, I have worked across multiple domains of project, from being digital marketing experience to post to the digital marketing experience, from e-commerce to analytics to the cybersecurity. Pretty much you name it, might have worked upon it. So today we are gonna that's about myself. So today we are gonna talk about. Uh, okay, slides loading fine. Performance. So my question is why performance? Why we are looking at the performance aspect? So in the today's digital world, you know that we are pretty much overcrowded. You name a problem, you will find a multiple solution for that. And where does you edge out to other solutions? It's the performance. If your performance is not good, the customer might move away to another project. So I'm gonna ask you simple one question. Uh, can you answer this question like any educated gets defined? What is the average load time of a web page before a customer moves away? 5 seconds. I can. These are the reasons. Yeah. If your site is taking more than 2 seconds on a desktop front, you might be losing revenue. Okay. For the mobile browser, if it is more than 8 seconds, you are losing revenue. And if it's the content heavy site, then 1 second you can add it up. Not more than that, right? So, what can we do that to improve? So, my first question is this example. Okay, there is a one basic silly mistake committed under this code. What is that silly mistake? If you can find it out. It is because of the mob mentality that we have. We would just want to finish our work. We don't want to look at like quality of the code. We just want to finish up, and it might be a small mistake for a small one file. We might not be looking at like saying that it's just gonna add few milliseconds. But when there are thousands of files and thousands of components, it's gonna be a huge one. Just tell us like what's wrong in this code. This is simple code. Yes. So most of the developers commit this mistake, and I have faced it a lot. Well, and when I look at the code, I see a lot of this statement. Suppose that there are 5 imports, they have done it in a one file, and there are 60 files. Then here they're around doing 300 imports. Kind of this statement. It's gonna take 0.1 millisecond extra for this one statement, one line of code, and imagine it for the 300 lines of such lines. It's gonna add huge amount of time in your performance like LCP basically. So what can we do? Take the basic features to avoid such problems. Okay, why it is coming as black? Okay. So it's kind of blocked, but I can explain. I'll read it out for you. So what first thing we have to do to avoid such mistakes is avoid unnecessary imports. Use the hooks, fragments. Okay, you can avoid uses of local storage. We generally do it a lot of use actually for storing the like cookies. You want to use it. You want to store a local analytics data. You use it, but you should avoid it. Okay. Now come to the like this is the most underrated function in the React. Okay, React menu. How many of you are aware of it? Have you used it? Okay. So I see few hands. Yeah, that's fine. So how does a rendering renders? Like first, how it when there is a props change, it re-renders a component get re-renders, and that re-rendering, what happens? That re-rendering will compare the data with your DOM data that is available, and then it will make the changes. But where this React memo can help us? So suppose that you have a parent component. We all have. I'm taking the example of this simple code actually, where we have three functionalities. One is movie title, and release date, and another is a live view count. Okay, so live view count is a real time data, but these two are not. So when you render like this parent component, it's gonna re-render everything if you use a default export. But if you gonna use this React Remo, what it will do? These two things will be in a separate component, and it will have a virtual memory there itself. What was the previous state data? It will store it up and compare with the new one. If there is no change, it will not going to render this child component. So imagine this. We are saving some time here by not re-rendering the child components again and again. And if you are going to look at the production level, so where you have the product catalog, whole catalog, and how many rewritings you're going to save it. This is the one thing that you can achieve with this thing. But you cannot use it everywhere, right? So you have to avoid it at some places. You have to do your due diligence. I will say that you have to analyze like where we can use it. If the states are varying infinitely, you should not use it because it's gonna harm it rather than helping it. So it's kind of over engineering if you are not doing the due diligence on this one. So have you seen this map? Anyone? You have to see. Huh? Bundle sizing. What's wrong in that? Okay, that is one.
copies of property.
Yes, that is also wrong. That is called dependency duplications. And there is one thing I would like to point out here is that index.js file. Have you seen that it is really big? It is not being chunked out. So what we can do, we can split out like what happens. Basically, I'll explain you the scenarios. When you load your page, these all these files with the help of Webpack get loaded in the form of bundles. Okay, when you load a website, it will come from the server side. Your client side will request to server side for these files. When the size of these files are too big, it's gonna take time from coming to your servers from your server side. So what we have to do, we have to split it out. We have to reduce their size. Okay, if we are reducing their size, what else we can do? Because reducing their size will not be sufficient. You can just reduce the size, small requests sending one by one. That will not be sufficient. So another thing that comes in the picture is this lazy loading. What is lazy loading? And you might have used it a lot. People use it. Have you guys? Please. Yes. So what lazy loading is do? So it will load the content first, whatever is there on your front end. Okay. When you scroll down, it will in background it will be loading up the bundle of files that is there in the background. Okay. So this is the in the performance, this lazy loading can really help a lot. So let's say that you have a dashboard page where you have the graphs and all these things, and the below down you have the order details and everything. You're not gonna your user will not gonna see this orders and all these in details. He just wanna see the graphs. Why are you loading it? Why are you waiting it for it? Okay, so you first what you should do, you should lazy load, apply the lazy load to your component. Okay, those the kind of features that is there on the above dashboard, you should bundle them in one separate bundle, and the lower one in a separate bundle. So this way, and then apply the lazy loading. So what will happen in after that? It will load your first whatever the first bundle is there. It will load the first one, and it will present it to the customer. It will not have that, yeah, we have the syncing icon like loading icon is there. He will not face that kind of issue because of this. Okay, and in the background the second bundle is getting loaded. When he scrolls down, he will have the second bundle. So one question I have faced a lot is like, when should we chunk it out? Like, what is the sizing we should have it? So, as per my experience, we found out that if your chunk file for the bundle size is getting more than 2 MBs, you should separate it out. If your site is content heavy like ours, then you can keep it till 3.5 or 4 MBs, that at max, not more than that. Okay. So this is some basic example of code if you might not be aware. So that's why I added it up. Like if you can have it as a reference, like how can you can achieve it. This one. So what we are doing here, we are applying the lazy load function here and splitting out our functionalities like in a different bundles, like home functionalities, whatever is there in one bundle, and the billing page functionality in one function. The features that we have that we reuse it on the every page that in one features and sorry, and the other kind of function, low using function, and the function features B. Such you can achieve it like it depends on your educated guess, like how you want to achieve it, based on your requirements, based on like what is the ask for your organization. Okay, and this is the third, like as he mentioned out, like movement.js. Why were we were seeing that big movement.js file? Because we were not having up to dated version. So sometime what happens, we will have the older version and it will get up to date, and they will optimize it. They will reduce the security flaws in that functionality. We have to look out for those new versions. We should cannot be static with the older version. We added it just once and we didn't checked it out. Neither of us check out when the build happens. It gives us the warning that this there is update version available, but no, none of us do check that. We should really check it out. And what happens, like most of the cases, what when we check out our project, we let's say that we are 10 developers are working on single project. So for same functionality, there might be different npm packages available. So all the developers might be using some different packages. That will create the duplication issue, and it will increase your bundle size as well. So we should look out for those things as well. And we should also, one thing that we should look out for, the what's the bargain here, like what we are trading off. If we are adding something, we are losing something. Let's say that you are adding a good movement.js package that we are you don't have to write the functionality for the date time. Okay, but you are adding something to bundle size which will impact your performance. So we should avoid doing that. Okay, and the one example is that, like, whether it is necessary to do that. In my case, what we found out that SHA-256 encryption, you all might have been aware of it. So when you're doing encryption, so in React, there are a lot of packages available for it, which might quite go to 256 kbs and 512 kbs, something like that. But what I found out that with the help of writing just three lines of code, you can achieve it really easily. Why you want to add a dependency for that? It's not like we just want to reduce our like effort. That should not be the case. We can add it those smaller and simpler functionality by ourselves. We need not to go for the dependencies. Okay, so now coming to the next topic, all where we can improve the performance, throttling and debounce. So have we have all seen has that search bar. So in that we have the auto suggestion keys, right? So when we click the first keystroke, then there will be auto suggestions. When we hit the second keystroke, there will be a suggestion. But how does that works? Our system cannot be that fast, right? So what we do, like where it can, like these are the operations that are quite expensive. You make it operation, it will be there will be thousands of results. It will querying down and giving you the result, and then you hit the second keystroke. There will be multiple keystrokes. Like users can hit the 16 to 20 keystrokes as per our analytics data in a search box at a time. Okay, so that's where we are losing some performance. Okay, so what we can do, we can apply the debouncing, right? So rather than querying it directly one by one, we were having the delayed response. So rather than doing that, what we can apply the debouncing, right? So what debouncing does, like it will apply a timeout. So if a user hits a keyword, it will wait for some milliseconds. Like, so let's say that it's up to your use case how much you want to wait for it. So you will wait for that time. If the user doesn't hit the second keyword, you will query the data. Okay, if he's not hit it, he has hit it, then the timers will restart, and it will again wait for that amount of time to execute the query. That is how this debouncing can be done, and it can help you to optimize this expensive queries that you've done on the auto keyword suggestions, all these things. Okay, this is the one basic example that I have taken it out for the how you can create a debouncing function you have not created up. Okay, I'll provide you the PPTs that you can refer it up later for your reference, that how to create it up. You just need to create a debounce function which will return a function, and it will have a timer in it. You can provide the a time how much the time you want to set it out before it gets set out. Okay, flushing. Sometime what we need to do, we need to run the actions before the delay. Okay, let's say that there is a priority task that we need to run. Then what happens, we have the applied the timer, we need to flush it out. We need to avoid these timers for these things. Okay, so that can be done with this flushing. So in this case, what you have to do, you have to just write one more function here, and uh, mind with this debounce function. What will it will do? It will store the arguments that is being rendered by like this function. Okay, and saved it for the later. First, this priority task will execute, then the next one, like that the delayed one. So debouncing is not that simple. You have to look out for the real time cases, because there are chances that there might be priority tasks, there might be greedy tasks that you need to be run fast, that you have to look out for. Because and it this debouncing can be also be achieved with the third party tool, that load dash fishing. We will say if you are developing a React project, and that too at an organization level, you might have this load dash for multiple reasons. Okay, so there is, in this load dash you will have this functionality, or if you want to go through the code, there is available in the git that you can refer it for this debouncing. Another thing we can do is the throttling. Throttling is exactly opposite of the debouncing. Okay, we want to minimize the number of queries in a time period. We don't want to perform the n number of queries n number of time in this limited amount of time. So where it can help, so there are chances like when customer do resizing of your product, like minimizing, maximizing, and in the React case of the React, it re-renders. All these components do get re-renders. Okay, so that's where we can apply the throttling. We can just cache it out the result that we got the first time, and store it up. Okay, and re-render that result. Or we can, what we can do, we can have the states. In the states, we can store the data for this different type of sizings, and we can present it up rather than re-rendering it up. Okay, like now comes to the part like when to use the throttling and when to use the debounce. So if you are not concerned about the intermediate result, then you can use the debouncing. But if you are concerned about intermediate result, then you should not. But the throttling is that like if you need the intermediate result, like the fast result, I will say that. Because if you don't want to wait show that loading icon, then you should use the throttling. If you have seen the Amazon homepage, right? So they use that. Okay. So one basic mistake everyone also commits, that initializing the props in this constructor. I've seen it a lot. What happens if this props get changed? So this function will not re-render, because you have declared and declared the states in the constructor itself. So it will not get re-rendered. So rather than declaring this up here, passing this basically props here in this constructor, you should just declare it and pass it in a separate function. Okay, this is how the exact way you should be doing it. Okay, and there are other life cycles methods also that you can use, that should props the update, and you can this would be a better solution for such kind of problems, rather than directly creating a function, because this is inbuilt and available, and it is highly optimized for that. Okay, so ways to use the lifecycle method. So what I have seen across many organizations, like they generally don't use this lifecycle methods properly. And I'll take an example of this should component update. And what was the first one? Component will receive props. Okay. In what cases should we? This is really a beneficial function. Should component update lifecycle method for our performance aspect. So if there is a change in your props, okay, then only it. If you're using this lifecycle method, then only it will re-render your component. Otherwise it will not. So it's really helpful out there rather than using the first one and declaring a separate function, or declaring a separate function for that. Okay. So another topic I would like to cover as primary short, like gzip. So generally, what we have, the bundle size of our project is too long, right? 7 to 8 MB. This is another tool that we can use it up to compress it to into KBs. So it's a third-party tool. What it does, you just have to add its reference in your webpack, and in your webpack, after that you have to just add the one-line code to identify your web server to that this file. It do generate, rather than generating bundle.js file, it do generate another type of file that is called with the dot gz files. Okay, you can use those kind of files rather than using bundle files, and it will really help you to improve your performance. You can zip out your first images with this tool. Okay, you can zip out your bundle files. You can zip out your css files there out there. Okay, so I guess time is done. Questioning will be there in the Q&A. Thank you all.
Thanks, Himanshu. Just on like because to the audience, so I got a few complaints saying like the people who are sitting in the back, they're not able to hear properly. So please be quiet. Make sure that whatever the speaker says is audible throughout the entire. And I also see a lot of empty seats on the front, so you guys can come to the front as well, the back benches. Cool. So going with the last talk, we have Cyrus with us. So he has been experimenting with Next 13.4 lately, right? So I hope that he'll get some great insights from his talk. Yeah, welcome on board, Cyrus.
Hello everyone, my name is Cyrus and I am working as a software engineer in GeekyAnts. So I have been experimenting with Next for a long time and I'll be discussing what are the new features that have come in Next 13.4. So I would like to ask that how many of you have tried Next and built apps with it? Cool. So, with the Pages router, as you must have read that in Pages router we used to create pages inside the directory, and we could create multiple pages using the Pages directory. So I'll be at initially I was very overwhelmed by the Pages directory, but later I realized that there are some flaws in it. So I'll be discussing also in this meetup. So, how many of you know server-side rendering? Because this talk will be mostly around server-side rendering. Okay, so for those who don't know, I'll explain to you. So if you create a normal React app, then what you like if you put local 3000 localhost 3000, then what do you get is a JavaScript bundle from the server, and you get an initial as a empty HTML file. So the JavaScript bundle that you get gets loaded. It executes its task. It loads the DOM in your browser, and you can see the whole React app. But this is very time consuming, and it is not very performant, because the whole execution of tasks that we wrote for your components is getting executed on the browser. So what Next.js has done is that it has introduced server-side rendering. What you can do with server-side rendering is that you wrote a component, like I create a component app and I put h1 hello world. So what it will do is that in the server only, it will create an HTML of that hello world, and it will send back to me to my browser. So it won't be sending me the entire JavaScript. It would be sending me an HTML on my web page, and that would increase my SEO, and I could see the HTML on my browser. Also, it sends some little JavaScript, because if I add, suppose, if I create a button and I put on-click listener onto it, so it will the on-click listener won't be can't be executed on server, right? Because it is a browser event. So what I get from the server is the normal button element, but on the JavaScript that I get from the server-side rendering, it executes. It's a little bit JavaScript. It executes and put my on-click event onto that button, and then I can interact with that whole page, right? So this is what is called server side rendering. So it is all perfect, but there are still some flaws in server side rendering that we'll see in the next slides. But the one flaw that I can see is that if you have a suppose a component that you want to show a list of post in your app, so you don't have any interactivity on that post, right? You just show a to do app where you can see all your to dos. So there is no need of sending the JavaScript bundle on that on the browser to get that executed, right? So what the drawback is there, that for all the components we are sending the JavaScript bundle also, and we are also sending the HTML from the server itself, but we are also sending the JavaScript for all the components. So if there was a way that we could differentiate server components, like I could differentiate that these components should be only be rendered on the server, and no JavaScript should be passed from the server to execute them. And if I could have some components that I know that they will be executed in browser, because they have some event listeners added to it, we need to access the local storage that are only the browser events, right? So if we could differentiate between them, then it would have been very easy. So what in 13.4, they have introduced React Server components. So let's go to the next slide. So the topics that we'll be covering in this meetup is the first is the app router. This is the main part, and the server actions and the turbo pack. These are all they are an alpha version. So we'll be mostly talking about the app router, in which we'll be talking about the React server components, which I told you. We'll be talking about data fetching, and we'll be talking about routes and layouts, right? So let's start with React Server component. So as I told you that we need to differentiate between between two components. There should be server side components and client side components. Server side components shouldn't have any JavaScript to be executed on the browser, because for them I only need to get the HTML that I can preview. For client side components I need the JavaScript, because I need to click on a button, hover on it. So these are the all the events that client side components use. So this was the main idea behind introducing React Server components, but this is not it. There are many also other reasons why React Server components were introduced in Next 13.4. So why React Server components? So as you may have heard of waterfall problem. How many of you have heard of it? Waterfall problem. Okay, no one. One. So I'll show you the code. Can you see this code? Okay, let me. Now, okay, so let me explain you verbally then. So let's suppose I have a component. I have a three. I have a parent component. I have a child component, and inside that also I have a child component. There is a three-level parent and child relationship, right? So if I want to execute my child component when my parent so there will be three components, like first, second, third. So if I want my second component to be rendered only when first component has rendered, and I want my the second component, the leaf component, to be rendered only when second component has rendered, right? So what I'll do is that in my parent component I'll execute my async action. In use effect I'll call my API. Then I will see that if loading is true, then I'll show loading, and if loading is not false, then I'll show the child component. So similarly child will also do this, like if it will get its own data, and it will show if loading is true, then it will show its loading is true, and if loading is not false, then it will show its child component. So you can see that the third component is the child component is dependent on the second component, and second component is dependent on the parent component, because only when the parent component will be rendered, the other components will be rendered. So this is called a waterfall model, right? So what can we do to improve this? So what if I could tell my components, all my parent child components, that you request for data only in your component, you don't depend on the other components, right? You just call your API in your own function itself. So this is like the waterfall model. And it what this can be solved by React Server components, because in React Server components we can call our API. We don't need any use effect or anything sort of that functions use that hooks. We can just call our API inside on our server component. So like if I have my parent component, it can get its own data in its own component, the child will get its own data. They will not be dependent on the other components, right? So this is the one problem that React Server component has solved. This is the second problem that it has solved. So a render only required components on client, right? So as you can see here, so we have navbar here, we have search here, we have sidebar here, we have main element here, button. So also you can see that they are denoted by different colors. The server component has different color, client component has different color. So we don't want all our components to be executed by the JavaScript bundle, right? I just suppose if I have my navbar, I will show my only image there and some text there. So it don't need any JavaScript to be executed, because it can be rendered on the server. But for search button, I need to input my the text there, and I need the browser interactivity. So we have divided these components into server and client. So the client components will be rendered on the server also, but they will be getting a JavaScript bundle that will be executed on the browser, and we would be able to see the interaction. But for server side components, they won't be executed on the client. They would be only be executed on the server itself. So what this has done is that it has reduced the JavaScript bundle to very low. Like the JavaScript bundle is very less, because the server components have a JavaScript bundle of size 0, because they don't need any JavaScript, right? Only client components need the JavaScript to be executed. So it has reduced the JavaScript bundle to very low. So yeah, this is the game changer for server side rendering. Previously, a simple hello world app would require sending over 70 KB of data just to have a div. So now if we don't need interactivity, why I just want to send a JavaScript bundle to my browser? So only thing we get is a HTML and a CSS and no JS. So this is like a game changer. The JavaScript bundle will be very low. It will improve your performance of the app, and there are many. So yeah, advantages is massive savings in bundle size. Initial page load will be faster. You don't need to optimize your other things like used to do in React app. It will be very fast. SEO will be improved. SEO was improved in 12th point version also, because I also used to get the the HTML from in Next 12 also, but in 13 it has been improved much more. And components are server by default. Like if you create a component in Next 13.4, they will all be server by default. So if you want to make it client, you want to make if you want to create a button on in your if you want to add a button in your app, then you can use client directive. You can place it at the top of your file, then the JavaScript will be sent to the browser, and you can use client components there. But for server side, they are the components are by default server. Right. So this is all about the React Server components, and this has been in the app router that has been released in 13.4 version, because in previous version 12 version there were some problems that we'll discuss. But like there were pages directory there where we used to send all our we used to keep all our files to load our pages. But in the next 13.4 we have an app directory, and we have layouts. You can explore them in the next.js docs. They are quite good, so you can explore them. And routing, yeah. So Next.js has introduced a new routing. It is a completely different architecture because it enables React Server components. It allows you to use React Server components. And if you have heard of React Streaming or React Suspense that has come in the latest React 18 version, it also enables us to use that. So these is the you can see that dashboard layout is there. So and like every page that you can create in Next.js will have a dashboard layout, and this is a root layout. So root layout is the layout for all your pages, and dashboard layout will be the pages of will be the layout for your individual page. So if I create a dashboard, it will have a dashboard layout. If I create an admin page, then it can have an admin layout. So we can separate every page with its own layout, and there will be a one root layout which will be sitting on the top of all my app, and we can do any sort of stuff here. We can put HTML body here and HTML tags even here. Okay, so next, so the features of this routing is like route groups. You can separate your routes from each other. You can have different layouts in them. You can have dynamic routes. Like in 12th version, we used to have slug file dot slug file. It is almost similar to it. Now we have parallel routes in routing. Like if I have a layout, if I have a page where I want to show two different pages, so I have a analytics page and a dashboard page. I can combine those two pages into my one single page, and that would have their own loading states, error states, and all stuff. And intercepting routes is like what if you have created, suppose if you have Instagram, right? So you can see you have a list of feeds on your first page, right? And you can, if you click on in a post, then you go back to another page of it, right? So intercepting routes is that if I just like if I press photo of someone, a new modal will appear, and the page of that person can appear. So this is about intercepting routes. Like I can load a different page altogether into the existing page that I have, right? So middlewares are there. Like you can like run your code before the request is over. You can redirect it. You can change your headers of your requests, right? So these are the features. And simplified data fetching, this is an also a game changer in 13.13. So no more get static props or get server side props. So in 12, what we used to do is like we used to wrote different functions, get static props and get server side props. to get all the data. Then we used to pass that to our component, and it was a lot of heavy stuff that we used to do. But now it's not like this. Like we can write our own async functions inside our component itself. So this is how I feel calling Prisma directly in server component. So I'll show you an example how we used to write, how we are writing it now in 13. So yeah, I tweeted last year that one of the problems with Next.js that I faced is that for showing my data in like, suppose I have different pages like home page, dashboard page, other pages. I used to have a header in every page, right? So what Next.js in 12, what we used to do is what we used to call our get static props and get server side props that I showed you a function that I showed you in the last slide. We used to call that all our functions. We used to get our data, and we used to pass that to our every we used to pass that to the header component every time, because these were the header were the persistent component. It sits on top of every page, right? So we for showing our data in the header component, we used to write our async functions in every page, and then we used to pass that to the header. But so that was very like hurting us, because it was a lot of code, and bundle size were also increases. So now last year there were the RFC was going on for the layouts. So now in 13 they have released the new layouts RFC. So that solves the problem of not passing my data every time to a header component. Why? Because they have introduced React Server components. I don't need my every page to send my data to the header component. I can just call my async function inside only the header component, and that would execute every time. No need of sending all the data from every page to my layout components, right? So this was the problem that is solved now. And yeah, so this is the React Server component. I tried some experiment few days back where I used a Prisma ORM to get data. Like I created a users table in Prisma, and then I like get that data inside the component itself. So you can see that I just called Prisma, new Prisma client. I initiated the client. I wrote users is await Prisma users dot find many. This is an SQL query. It is running an SQL query inside your React component. So like this is a game changer, because we used to write APIs for, we used to call user fed, we used to write APIs for it, then we would get our data, then we used to store loading state, other stuff. So this all the heavy stuff is like compiled into this one, because we just need 2 lines to get our data, right? So this is very cool. And we can use async and await in your server components. So combine SSG, SSR, and ISR. So there were 3 different methods of building your app in Next.js in 12 version. It first one was server side static side generation, like where I used to build all my pages on my build time. There was server side rendering, which I told you before, that every time I call my browser, the day I would get a HTML from it, and all the data would be executed and sent back to me. And ISR was like incremental static regeneration, where I could put a validate of 10 seconds. Like if I reload my site every 10 seconds, it doesn't sends me the data again and again. It sends me data after only 10 seconds, right? So this was these 3 functions were there in Next 12. But now, due to these server side components, the Next.js team has using fetch, the JavaScript fetch, and we can pass, like if I put normal fetch here, you can see that it is cached until the manually invalidated. Like if I reload my page every time, it is similar to SSG, static site generation, because data won't be coming back every time, right? And the other is no store. If I put cache as no store, it means that it will be refreshed on every time, because it is similar to SSR. Like if I anytime if I reload, I would get all my data again and again. And the other is similar to ISR, cached with a lifetime of 10 seconds. Every time I reload my app, the data won't come every time, won't be executed on server every time. It would be executed after every 10 seconds. So this was the advantages. Like we used to write whole functions inside our React components in next 12, but now this has eased a lot. Yeah, so also talking about in next 12 we couldn't combine these two. Like if you see that I want my some pages to be some async function to be refreshed on every request or cached with a lifetime of 10 seconds. I couldn't have that option in next 12. So now in 13 I can have three all three running on the same time. So this is very like cool because earlier we couldn't have this feature. Right. So server actions, yeah. So server actions has also been in alpha right now. So this enables us to write our async functions on the server itself, calling those functions without in our cider components without needing the use of actual API. So when I want to create a user on my DB, what I'll do is what I used to do was like I could you need to create an API, send that form data to my API, then it would parse that data and send to the backend, and then backend would do all those stuff of inserting in DB. But this is not the case in here. So it has reduced client-side JavaScript. So enhanced user experience with features like optimistic updates and progressive enhancement. These are experimental for now. Like optimistic updates is like I can make my changes on the client and I can tell my client that this has been done, but I send my request to server, so server will tell after some time that it was true or it was a success or failure. Until then I tell my client that this was a success. So after the request comes I can optimistically uh, check that if it was the response was success or not. So other is great developer experience by making it seamless to offload data updates. I can just in my client components, I can make run my SQL queries in my client component, which would have required an API in the past. So you can see an example here if you can see. So I have created a create user function inside my component that, and I have added a directive use server here. So what I do is I initialize the Prisma client and I create a user here, like name. I get the form data from the JSX I have written here, and I can directly put my data on the backend itself with on the DB itself without needing the API layers. So automatic code splitting is there. So in server side components, as you know, we can write async await inside our component itself. So I can on the basis of a boolean variable I can show which dashboard I want to which user which app I want to show. Like if you have seen Swiggy Instamart or Swiggy food delivery, they are total different apps, right? So if you can see here, if I am logged in, I show a different app, and the landing page if I am not logged in. So this has decreased the bundle of JavaScript very high. So no need of like getting all those JavaScript into my browsers. And so turbo pack, this is in beta because this is in beta. So the features are like it is faster than webpack, so it is also faster than white, and fast and flexible development experience. It also decreases your bundle size, and it has a very developer friendly experience. So yeah, I have created a. I was trying some to, experiment few days ago with using Prisma and Drizzle. Drizzle has is a new thing. It is an also an ORM which with type safety. So I was trying that. I'll play a video here. So you can see that there is a schema here, and I have for Prisma, and what I have done is I have this is the drizzle. I've created a railway app where I can adding users on the DB, and as you can see, I go to my localhost drizzle users. I reload, then I can automatically get all my uh, all those data that I have inserted. So let me show you the code where it was. One second. One second. Yes, yeah, this one second. Uh, okay, I'll show the code that I had written for the fetching the data. Yeah, so this was the code I had written inside my client component, and I was just getting all my users from the DB itself. No, I was not using any backend API here. So this was only the code I could insert my data into the backend, and I could just use it to show my all the users. So yeah, thank you.
Great presentation, Sayas. I think I haven't also personally, explored 13.4 yet, but things looks promising. So I love, merging the features of SSR and SSC, and I have like high faith on server actions. I mean, although like a lot of features are still in alpha or beta, but then I hope things. I mean, at least as of now, things are looking promising. Cool. So having said that, we have been into almost at the end of today's meetup. So we'll have another segment remaining called the panel discussion. So for that, we'll be having all the speakers on stage and just I mean give us 10 minutes, 10 more minutes to prepare the stage, and we'll back with the panel discussion in front of you guys. So stay tuned till then. Thank you. So attention guys once again. So cool. So we are going to start with the panel discussion. We open to any questions that you guys have. So you can start firing us the questions. No one? No question from the audience?
Hi.
Hi. So you talked about server components and server side. Is it like ready to use for production or it would like it has some time?
So this server components come in app router. So Next.js has told that in 13.4 the app router is stable. So yeah, we can use it, the server components.
And for example, if a page loads and it loads half of the components from server and half of the components from client, which may have interaction. If you go to next page, it says to be available because of next router. So will server components start streaming components for next page or like how it will happen? Because that page is not getting reloaded. It's an SQL.
Yeah. So I think I haven't explored much, but I think it will be the if we go to another page that will it will also like it will call its the data will come from the server and it will be executed. So it will be like based on the basis of priority of my interaction. So if I go to a next page, it will be loaded. But if I come back to my page, I think it will be stopped for like it won't be asynchronous. So after I come back to my page, then it will start executing because now if you see the streaming has come, React 18 streaming has come, so it is based on that interactivity, like the priority of interactivity. It will pause and then the other will run. So I think it's similar in the case of the navigation between pages.
I think the basic stack is not gonna go anywhere. It is same like earlier as well, right?
Yeah, yeah.
Say for example, if I'm having a server side prop, and then I'm going back to the next page and coming back again, like going to the next page and coming back again. So that is not gonna read in the
No, 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 that will
so
not
basic
be.
stack I believe is gonna same. So it's just that I mean how do I describe it? So it's basically you can say an extra step modification to the existing SSGs. Right? Anyone else wanna put some point on that? Cool. Next question.
So, saying this, there were like server functions were introduced, right? Recently, but there are some modes which many of the viewers of there are already now. Let's say server component you try to update this global state. Let's say a page is a slide, use slide and it's a server component. And you say that server functions, go behind the scene and executes and come back. Let's say some part of the component has to update a state on the component.
I
And
think
in fact, you might leave some information if not useful.
I think you can't access the local state inside of your server components because
It's used client. As mentioned, use it's a client-based component, but the function is server. Like when I say use
yes,
server, it's a function.
yes.
There are chances that some might try to update only, but they are updating the state automatically from the.
So you can't use server action inside the use client directive. If I use a use client on my in a client component, you can't use that server actions. In client components, if you want to use, you need to pass that. You need to define your server actions in the server components, and then you need to pass it as a props to your client component. So client component will be a child of your server component. So you can't directly execute your server actions in a use client directive.
Anything else from the audience?
So can you explain more about server-side rendering? How does it?
Yes, so you can read also on the Next.js docs. It is quite well explained. But in server-side rendering, what I can tell is that if did you get what we get from the browser and JavaScript that stuff? Did you get it? That I was explaining. call in the meetup in my presentation. So, like if in server-side rendering, what we do is like we define server-side props in our component, and we can like request a fetch API inside my get static server like server-side props function, and then I can use that data inside my components, right? So every time I'll be reloading my page, that function would be executing every time. So this is called server-side rendering. But in the static side generation, what we tell is that only at the build times that page will be the fetch API will run. Reload the page every time the function that I have defined, the fetch function, the fetch API, it will not run. So it will give back me the old data. So this is the like the difference. You can like explore more on the docs. It is quite well explained there as well.
Like anyone want to take like add some point on that?
No, I think for static site generation and our normal use cases. So I think static site generation is one specific use case, which is like blogs, your about me pages. Focus on that, but everything else is either client side or recently like RSA components basically. Um, yeah, I mean the use cases are drastically different when you talk about SSR and SSG. That's I think one thing to be. That's
Another thing I would like to add with SSR and SSG is that for SSR, you will need to ensure that you have the right infra that can do it in the right amount of time, right? So as you scale, SSR and SSG will really come into fierce competition with each other when you're considering SEO and things like that, right? Because difference between how well you can implement SSR and SSG will be the result of will directly impact your SEO. So that's one of the problems that we faced internally at ZenDuty, and it depends on a case by case basis on what your infra is. So what works for you might vary.
So I might have a suggestion on that. So my rule of thumb is never use SSG and don't use a combined CDN or cloud front or something in front so that you simplify your architecture and basically do everything on server side, right? And everything will be cached by your edge cloud front and otherwise. So they can act as your you don't have to worry about uploading your assets and everything. I think that simplifies everything.
So
Central way to
yeah, that's a great approach. That's a great approach. And if you're just getting started with, and you have the choice between using SSR and SSG or not using it, you should definitely consider that, right? But if you've already got certain constraints to work with, or there may be other factors that come into play. Let's say there may be some authentication related tokens that may be generated for which you require a backend or your server to actually handle the authentication securely and things like that. You may not be able to just send everything from CloudFront or the edge, right? So it would depend.
So if you want to do it on server side, I think all the CDN providers provide you for Domain has cloudlets, CloudFront has hooks, and you can run code on edge. But I would recommend doing these things as client-side components because you should not block user experiences. It's block them authentication. And generally, if something is behind authentication, that doesn't need SEO, so you don't need SEO.
True, true.
Makes sense.
Could you regarding optimization? I noticed one point where you mentioned that you should not use local storage. So any reason that why you should not use local storage?
It will hinder your memory performance actually. That utilize your utilization. If you use too much of it, right? What I said, it will hinder your performance like memory utilization. So when you run a processor, like in the code as well, run some processor do run. So this local storage, when they exceed the certain size, it will consume a lot of memory that is supposed to be consumed. Okay, more than that. So that's where it comes really bad. And the other thing is that security flow. Your local storage is easily accessible if you are hacking it, someone is hacking your site, right? Your local storage is easily accessible by the person.
But it actually gives you kind of, some things which we need, let's say, when I log into that page.
Yeah.
At that point, I need user details to be captured and just name and all, stuff details which I need to store in the header in all the other pages.
Yeah.
So first it is one, part which I can take. So apart from that, we have to give the suggestions. Let's say I log into that page,
Okay.
and header should show the name,
Name of the user.
and other details of the user.
Yeah.
Local storage would be a better option in that case, so that you don't have to go to the backend again and fetch your, the details of your users, right?
Yeah, you can. There are other ways, like in the props. You can also do that the same way. Okay, if there is no need to store the user details in the local storage. Without that, you can also check it with using props. I think.
Using props. So maybe you mean to say that kind of context API can store that in the
Yes.
But again, the context API, the problem is if you update your, any state there, all your child is again to a performance issue.
So for that, I mentioned right wherever there is change, then it need to be re-rendered, right? Those things can be taken care of.
So I would like to add to that. That's a good question actually. So I believe that local storage is not all bad. For some cases, you can consider it for minimal amount of data, right? So, but in your particular example of, let's say, just showing user data on every page, local storage may not be the right option. You could maybe just cache the response and use the cache. All right. You could maybe put it in context. You could put it in store, right? So Redux is a great way of actually persisting data across. You can use session storage, things like that. When you talk about local storage, Redux can also put data onto local storage. So there is this thing called Redux persist, right? So I would suggest rather than directly controlling local storage, which may not be the best thing to do, you could handle writing to the storage using Redux, and maybe manage a strict cache policy over there, where you invalidate the data whenever it's not required. But again, there are security issues, right? So recently, it was known that Safari was actually exposing local storage across websites and things like that. So there will always be security issues when you use local storage.
I will be actually like you told about readers, right?
Yeah.
Don't you think for simpler applications it's overkill?
Yeah, Redux is definitely too much
Let's say
for.
I have a simpler application, but I don't want to use Redux.
Yeah, you can
So
explore
the
other
only
options.
option left is either local storage or context API.
Yeah,
And context API, as I told, I have to update something, it will like all the time has to get redirected. Again, that also has some drawback.
you could also use a good query library like React Query, which will actually cache your frequently used data. You can also resort to other state management like Zustand and things like that.
I think the like query libraries comes very handy nowadays, especially like you're talking something about Apple client or React. Right? So these sort of things makes you like everyday use case a lot of easier. So yeah, I think that's something to.
Apollo provides a very good in-memory which you can use. You do not make your query repeatedly. You can fetch the same data as long as, for example, if it's first name, last name, you can assume it will not change a lot, right? So that's kind of a safe usage. With local storage also, I believe, for example, in that MFC architecture that I explained, the local storage kind of helps us a lot because it's very difficult to pass data down. But you need to make sure what you're storing. For example, so I was a big proponent of Redux initially, but down the line, the problem is that my tree gets too big, and I don't want to persist a huge tree in my local storage because that will point to exactly what you mentioned about affecting your performance. Because that tree can grow to any size, right? Especially if it's a big app. So I do think Redux sometimes is an overkill, but it's good if you use it in a global scope. Like you just store your really basic values right there. That's all.
I have like another one more argument to make on top of it on Redux versus non-Redux. So in general, if you're using Redux, I would suggest separating your components into containers, components, and stateless components. Because what will happen is each of your components will get directly coupled to Redux in that case, and you won't be able to reuse it. So Redux makes things so simple and scales so well that people forget about that these components can also exist outside an environment where it is not there. So they become really practical. So always, have a set of container components whose job is to talk to Redux and pass data to your stateless components. So I think that is something that will go well in the run.
Yeah, makes sense. Like a valid point. So, do you have any other questions from the audience? Yeah, Mr.
So I had a question regarding the microservices. How do we manage the state management in these? Like, do we maintain it in the shell itself, or each micro frontend would have their own state management?
Each micro frontend should have its own state, whether it's context, whether it's like whatever you want to focus on. But each micro frontend should have its own. Um, the reason I say that is if you have a global store, right, and that you're passing down to each of your micro frontends, then other micro frontends are getting access to the same information, at least the same tree, right? And that defeats the purpose of what we are actually trying to do, which is separation of these concerns. Like, I should not be able to know what the supplier data is. What if it's cached inside a Redux and I am logged in as a purchasing guy, right? And I don't care about that information, and I should not be able to ideally access it. So, if your separation of concerns is ideal, you should have individual stores, and they can be purged uh, when you come out of your micro frontend or when you enter your micro frontend. But yes, there also has to be a global store, which is currently the exact problem that we're struggling with. Like, we want our shell to also have a store, but we want it to be very minimal, and that data is not sensitive to any of the micro frontends. So I think it should be separate, but one small global store gets access by each micro frontend would be the ideal.
But would it be cross issues if certain, let's say my one micro frontend uses certain models and the other one uses Redux.
Yeah.
So how would the data, if I want to pass the data into the other one, into place where I'm using data, so would it be cause issues by communicating the data?
No, but it depends. If you are sending data, right? So you basically from your shell you make callback. You say, hey, get this data from this micro frontend, call this function. As soon as this function responds, you pass this down to your other micro frontend. So what's happening is you're not passing your mobile stores, right? You're not passing the mobiles of it. You're passing the data part of it. So at the end of the day, for example, Redux persist was mentioned, right? What does it do? It just stringifies the whole tree, right? At the end of the day, so what you're passing is a string. What you're passing is actual data. So if you want to pass that, then it's fine. Like, you can pick data up from mobiles, pass it to Redux, put it in a follow client. It doesn't matter. At the end of the day, it's a state management library, right? And you shouldn't get too attached with it. Use anything. And as long as you can pick data efficiently without a lot of overhead, it works.
And it's like one more doubt I have. Is it possible to mount the microfrontend based on the user roles? For example, let's say if I have a user that only needs maybe 3 or 4 microfrontends, while if it is an admin or supervisor, I need all of the microfrontends as well. So in these cases, I can optionally render only or mount only these microfrontends that are required, or I have to do all of them.
Yes, I get your point. So you can optionally render it, but I don't think with the current Webpack implementation you can optionally mount it. Because at that point, when basically the Webpack config assimilates all the micro frontends, the user information is not at play at that point of time. Because your auth might be a micro frontend, right? With sign in, sign out, reset password, or change password. And that's a separate micro frontend. That's my auth micro frontend. Now, unless and until it gets prompted, it starts interacting with the application, before that, you don't get the option to mount or unmount. So I think we can obviously render it, but with my experience, I don't think we can mount it. But, yeah.
So I have to like mount all the whenever I use the combination of all the microcontrollers.
Yes, but if you use lazy loading properly, it will never be. It will never take into your time. It will never take into your time and space because if you don't have the render for it, it's basically not wrong.
Cool. So anyone like want to add up anything with that?
To add to your question about having multiple state management libraries across micro frontends and how you would share data between them, right? So there are these things called middlewares, right? Most state management libraries have something called a middleware where you can have custom parsing logic as to how to handle the get and set of data. So if you are at a point where you have scaled that much that you are using micro frontends with different state management libraries, you may also be at a point where you can look into implementing middlewares because they can do that.
I think like the major thing, right? If you are using micro frontends, first of all, like make sure that any of your MFAs does not communicate a lot with the other MFAs because that's a very basic thing, right? So if you have a lot of data dependence with the other MFAs, that is going to be a very big pain in your very wrong place. So make sure that because if you look at like the traditional, monolith versus MFAs, right? MFAs are meant to be independent, right? So that's why you are making it as a different repository as well, right? And then to work with your distributed team, wherein the other teams who does not have any dependencies with the other MFAs or the other repositories, they don't also have to have the learning curve of the entire application, right? So that is one thing, and I think again, like I agree with what Pranav said. It's something like basically if you look at data process also, right? So it's just passing the data in a stringified format, right? So probably you design a small store for your sale application, and then you just pass the data in terms of string, right? So that's what I think you have to figure it out. So number one is like your data sets for a single micro frontend should be responsible for that only in most of the cases. Right now, I understand like there might be some scenarios wherein you have to communicate with the other MFAs, right, or with the sale applications. If it is something like, say, for example, like an auth token or something, you can already like always use a JWT decoder or something similar. But then you have to have a control and an idea on what kind of data you are gonna share across all the MFAs. So that's something I think is a very deciding factor in case you are using MFAs.
Also, I think that is advisable to use authentication part as a separate micro content, or should it be integrated in the service?
I would say again that depends, right? So if you look at most of the applications, like your auth token is something which like enables you using the other modules, right, of the application. So I don't find any difficulty. I would say while using it as well as a different micro frontend size. Because say for example in a microservices architecture, we do the same thing, right? So we would like make a different microservice called say for example auth, and then that is gonna auth microservice is basically making connection to your routes throughout the application. So I don't see difficulty implementing auth as well as a microservice. But then again, like say for example, if you are like trying to make sure that your auth has to be like communicated frequently with like respect to the other images. The other way you can design it is maybe like on the sale application, right, wherein the auth would be a part of your main repository, which like again like stores the data somewhere, and then you communicate with that data to the other images. Okay, cool. So, any other questions? We can take two more questions. Yeah.
Yeah, I have same question on the micro frontend. Like how do we ensure that all teams updating the latest version of the shared dependencies at the same time?
Deprecations.
Uh, so I think for example, React and React DOM might be a common dependencies. So you can configure Webpack in a way that it will fail if they have preferred versions. But as long as it's not something like which kind of runs the whole thing, like React, if it's like, for example, material UI, they can use different versions. We shouldn't, that's the whole point, right? That we should give that flexibility. So as long as they have that flexibility, it's not a problem. Like one micro frontend that I have uses hook form, the other uses format, and one uses a different version of hook form, and one uses material UI 5. So MVI 5 and MVI 4 are like poles apart, right? So it does not conflict a lot, but it does help if you want a design consistency to be there to be on the same version. Uh, you can force it if you share the library, but then yeah, if they auto update, it's gonna fail, it's gonna cause more issues. So ideally, don't force it. Um, but yeah, if you want a lot more consistency, then maybe a better idea would be to have your shared component library which follows your own design system, and yeah, just control its release, and that will kind of work.
Adding to the absolutely, they just put the microcontainer as a Monorepo and then you have a separate common package or JSON which have all the dependencies required and you want them to be common to all the applications.
That's like
Will that be
it won't be complicated, but my point is that now we are kind of centralizing a lot of things. So as long as you don't have to do it, I would suggest you not do it. Like have minimal dependencies. Let them work on their own. They are like individual units which are at work, right? So for example, if I'm running my microfrontend in dev mode, I will not be able to access the other microfrontend at all. Because when I try to access it, it will say probably page not found because that route is not registered here. It's only registered when you access it through the shell. Uh, so yeah, we can do that. What you mentioned, that's not a problem. Uh, but yeah, if you really want to enforce the versioning part, then yes, that can be done.
So I can take one more question from the audience. Anyone, if you have anything.
Oh, can I pitch a question to Pranav?
Sorry?
Can I pitch a question to Pranav?
Yeah, yeah, you can.
All right. So, Pranav, I have a question for you. Um, so, remember how you said you're looking at global state management through a shell? Is that what you said?
Yes.
Can you elaborate on how you're doing that? Are you using a package for that? And are you able to do it dynamically in based on real-time customer data? Where is the shell stored and how are you doing this dynamically?
So this is, I'm not using any library for this. I'm not using any of the state management or context for it. It's very straightforward. So my shell has, for example, what I want to do is not mutate data. What I want to do is make that data accessible. Because if I mutate data from any of my children, like any of the MFE, that kind of defeats the whole purpose, right? So if it has to be mutated, you might as well keep it there, right? So my whole point is that, for example, auth and stuff is in my shell. My navbar components, if this should display or not based on permissions, is on my shell. Right?
Constants.
Yeah. So I just pick them up and I use callbacks to handle it, and we can, if there's a change to it, right? These functions reside in the shell, and the functions that mutate them reside in the shell, and the actual data gets passed down as props. And it's a very straightforward setup. It's not.
That makes sense.
Yeah.
That makes sense. Because I was wondering how you would have mutable data in shell.
No,
Because
that's the whole point. Yeah.
Yeah.
If you want to mutate it, don't
Yeah.
keep it.
Makes sense. Makes sense.
So I have a question to Sayan from the audience who joined us online on YouTube probably. So the question is, what are the drawbacks of Git submodules?
Git submodules. All right. So there are several drawbacks to Git submodules, especially if not done right. Let me emphasize on that. So large, very strict teams are able to do it well, but some of the hassles would just be managing multiple repos and sub repos within each other, right? So let's say you're working on a certain component in a certain app, and you're working with a large dev team that has made changes to another shared component, right? Um, so how would you would have to deal with the hassles of which branch this is in, which version it is in, whether it has been merged, whether it has not been merged, and you would have to be switching a lot of branches. You would have to be pulling commits from nested repos. We would have to be pulling commits from the outer repo. A lot of things like this, right? And I've heard a lot of people, a lot of companies have been making these. Um, have run into problems with sort of relative repos and things like this. So what happens quite often is when you check out the parent repo in the Git submodule, you actually your nested repo branches go to detached states and things like that. So managing conflicts and cherry picking within large sub repos is a hassle. So, but that said, if your app follows a very strict versioning system and a very strict release policy and things like that, you can make it work. But it is a hassle.
Cool. So I think that's all from us today. Thank you everyone for joining us, as well as to the audience. So we keep, organizing these sort of meetups almost in every month, right? Sometimes twice a month. So do come up to the events. Do follow us on the social media and stay updated with us. Thank you once again.